All right. Thank you for joining. Just giving it a few more seconds while people are logging on. All right. So hello, everyone, and thanks for joining us this afternoon for Beyond Data Warehouses, CyncHealth's path to improving data quality. My name is Jordan Leibovitz. I'm part of the marketing team here at IMO Health. Before we get started, I want to take care of a few items for those attending. First off, we are recording this and it will be available to you later this week. So be on the lookout for this in your inbox. All attendees will be in listen-only mode. So if you have any questions or comments while Matt and Naresh are speaking, just type them into the Q&A box and we will get to them after the presentation is over. So today we have Naresh Sundar Rajan. He is the Chief Data Officer at CyncHealth, along with Matt Cardwell. He is our Senior Vice President of Client Services here at IMO Health. So without further ado, I'm going to pass it on over to you, Matt.
Great. Thank you so much, Jory. And thank you so much, Naresh. It's great to connect in this venue, and it's been fun talking together and revisiting a lot of the good work that our teams have done together. Hard to believe that it's been nearly 4 years since we began this partnership. I think rewinding the clock, all of us remember the story of 2020 and how we were contending with mountains of new data, reporting obligations during the pandemic. And I know a lot of that pressure was concentrated on information exchanges like those that CyncHealth provides. And since then, our teams have broadly deployed the IMO Health technology and data model to make the data that you're receiving from your participants more meaningful. Before we dig into some of the CyncHealth specifics, I want to ground us in a visual about what it is that we worked on together and the IMO Health technology. And so this was really about taking coded or uncoded structured data from CyncHealth that you're receiving from a variety of your data centers, a lot of those being health systems that are leveraging IMO terminologies within their electronic health records, but using the IMO Health developed matching algorithms to properly code those entities using our foundational terminology. We know data is fairly uneven, and certainly we saw that borne out in the CyncHealth case. And I know I'm looking forward to hearing more about this. I know our participants and those that are in the audience are going to be excited to hear all of what we've done together. So I'll tease that here really briefly. There's been a lot of work that we've done over that time. I think we started working to standardize the data warehouse. Shortly thereafter, the team stood up our real-time API to provide more consumer-friendly lab order names in the patient portal that you support. And then most recently, we automated some of the clinical data pipelines and are on average normalizing about 3 million terms per month. And by the analysis that we've done together, 84% of the time roughly, that uncoded data is resolved to standard codes without human intervention. And just as one measure of impact, looking at the terms that are normalized pre and post, there's a pretty profound difference in terms of how IMO enriches the specificity of that data using ICD-10 codes as one measurement. And certainly we'll come back to these numbers, but I want to lodge them in the audience members' heads right now, just in case it seeds some questions as you think about the impact to your own data. But before we go back to some of those specific measurements, Naresh, I know you have a pretty keen perspective on the impact that you see terminology services having for a health data utility like CyncHealth. So maybe just as laying the foundation in terms of how you approach this problem in your role, can you talk about why that's such an important aspect to providing value back to your participants and those that are receiving your data?
Sure, Matt. Thanks a lot. And just to probably begin with an introduction here. So again, this is Naresh, and my background is in informatics. So I've done a lot around health data for several decades, and interoperability is an area that I focus a lot. With CyncHealth, at high level, statewide health information exchange for the state of Nebraska and state of Iowa. The evolution of CyncHealth over the past 4 years, 4.5 years in my tenure here, we witnessed this move from a point-to-point exchange into mostly an analytics-driven, insights-driven exchange organization, which evolves into the concept of health data utility. So the foundation layer for this, in order for an entity to serve as an insightful data points generation, is to be able to produce meaningful, high quality data at the base layer, right? So that's when we started working with the foundation layers of data quality. There are event-driven profiling that you can look into. There are multiple ways you can approach the data quality. I mean, data quality is always a subjective domain, right? So an administrative system that produces data points versus a clinical system that produces data points at the same level of patient demographics can perceive it in different ways. So this added a lot of challenge for us because we get data feeds from multitude systems or multiple sources. When data starts flowing in disparate sources, such as clinical, electronic health records, pharmacy systems. In Nebraska, we have full prescriptions. So pharmacy systems is another example. Then we also get data from claims. We get data from social care systems. And there are several other augmentative sources of data that flows into our infrastructure. The challenge here is each and every source has its own specified standard of sort, right? Or the terminologies or the lexicals, how they follow. The ontologies needs to be efficiently managed at each source level. So for this reason, what we did is we were initially looking at ways by which we can approach the normalization in a meaningful way. Terminology server is by default the architectural component that we needed to provide as part of our normalization. And we were looking for specifically a modular solution, a solution that can actually be plugged into our infrastructure in a meaningful way that we can start querying across specifically for terminology needs and coming back into our infrastructure standardization pipelines together. So that's where we started with IMO initially. IMO was able to connect in both the ways. For batch processes, we were actually starting with SFTP-based bulk processing or batch processing loads. For transactional needs, we were able to get it at an API level. So that's the second layer. So these things lead to us first thinking about how we started our initial IMO maturity with CyncHealth specifically. Each one of our state has its own infrastructure, so that's another reason why we needed to do a modular infrastructure, right? So we are single tenant on each state, and the state-based infrastructure, jurisdictions and whatnot, that clears the data governance challenges for us. So with those things in mind, so the initial origination of this concept of getting the terminology server that is really to the point of API driven and also flexible in a way that we can actually bring it into our day-to-day processing of transactions. So that's where IMO got into play. Right.
Oh, thanks for unpacking that for us, Naresh. What did, just as a point of contrast, what did that data cleanup process look like beforehand in terms of, right, contending with that problem of poor data quality and trying to make your obligations for reporting and certainly serving the recipients of that information haven't changed. So can you maybe walk us through a little bit of that as we think about the meaningfulness of that 84% of hands-free normalization for folks that are responsible to data governance and that cleanup.
Sure. I mean, the 84%, we can talk about the 84% down the line as a metric by itself. But the point here is when we started this process of normalization, how things flew into is on a regular basis when we started onboarding systems, like let's say we onboard a particular entity or a hospital, a facility that comes into our infrastructure. So there is an ad hoc process today. So what we do in that ad hoc process is during our onboarding, we pick a sample of messages and we see during our UAT or testing of the systems, we see if all the data that comes into the system follow our compliance or our standards, right? So in our case, we were starting with USCDI V2 and V3. So that was our core on achieving the level of maturity. And we also have our internal specifications. CyncHealth has its own specification during onboarding stages. Let's pick, for example, pharmacy systems. Pharmacy specifically has an ASAP standards, right? So ASAP standard is for the modeling of the data and what data should flow into the system and what shouldn't. So that's one thing. Then for clinical sources, specifically, it was HL7 V2 for sources. So when HL7 V2 comes into play, then we also talk about the USCDI version 3 as our core model. So our goal here was how to actually make sure that we provide near real-time feedback back to the producers of the data, in this case, the EHR systems, how good the quality of data is, and what are the gaps that we have in the data that can actually be articulated meaningfully at the time of ingestion during onboarding. And then not only during onboarding, also to a point of efficiently running it over a period of time to produce those feedback back to those entities for standards and interoperability altogether. Exchanging meaningful information, the meaningful use all comes back to those using standard terminologies, right? So, so that's one thing that we've manually been doing for quite some point in time in our onboarding processes. So what we did with IMO was specifically looking at ways by which we could automate this standardization and also connecting it back into our scorecards per se. So every facilities would have its own scorecards. These scorecards are basically compliance to the standards on how good the quality of data that we're getting in our system is. Why does this matter? Because anything downstream, you brought up the point of a pandemic, right? So during that time, the ICD codes for COVID was almost misnumbered or misplaced or interchanged across descriptions and code systems. So being able to actually capture them all to aggregate to a common number, which we then use to send public health in near real time to actually produce reports which influences their policy and decisions at a public health level. So that was useful in how we actually automated, right? So being able to look at this continuously as part of our continuous development and quality improvement. So that was one of the key things that we were able to achieve in the process of automating it. So in short, the way how we approached is essentially dividing it into two parts. The first part is at a transactional level standardization and normalization. The other part is at a historical level, or looking at entire data warehouse level standard codes, distinct codes, and running them, refreshing them over a period of like, let's say 24 hours or a weekly cadence or a monthly cadence, and then run those reports back. So that's pretty much how we approached this. Overall, that's the way how we have automated to the point of 83% almost near real-time matches.
No, I think that's certainly a great metric and benchmark to hold in our minds about how this can reduce some of the operating requirements. What does that mean? Day in the life of the analyst. What are they able to support for your participants and customers now that they're able to spend less time in some of the data scut works?
So from an analyst point, maybe we have a lot of informaticists too, so analysts and informaticists, right? So informaticists are basically they are the ones who build metrics in the data for, let's say, one of the things that we do is quality reporting, right? Looking at it retrospectively on the data, pulling it together into quality reporting. So that involves in a lot of metric crunching for us. So the life of an informaticist involves in actually understanding the cohort selection almost all the time, right? Being able to pull the cohorts with the meaningful code sets for any metrics that we are actually pulling together. So the way how the normalized engine actually helped us is once we started that retrospective analysis on normalized engine, in which we brought in all the appropriate code sets and code terms, we used them as our standard cohort selection criteria for any metrics that we would start running across. So this became to a certain extent easy than us mining the data and adding a layer of NLP on top of it, and then coming into a curation or normalized curation, right? So when it actually gets into the point of identifying cohorts. So that was one impact. The second impact is upstream, right? So the upstream analyst or integrations analyst, what we call, they are at the level of whenever a new data feed flows into our system, they pretty much validate every single thing, like I mentioned before, for our compliance and standards based on our specification. So what happens is we know the way how certain entities have their own local code sets, and they were normalized to the standard sets using this lookups, right? So because of that process that get streamlined at the point of upstream, that is actually providing us a knowledge source for them to run their analysis, which speeds up the way how they operate in onboarding, as well as our integration engineers who has this embedded into their integration pipelines in a way that they utilize as a lookup engine beneath. So that access another day-to-day using IMO lookups for standards and normalization.
No, that's great and really impressive in terms of the way that your team is able to plug that into so many places within the data pipeline. One question that came across the wires while you were sharing that last response, Naresh, was regarding the confidence interval that you were using to normalize the clinical data. And I might just interject one piece. We didn't go into it, much in the way of some of the product features and capabilities, but both with the SFTP for bulk normalization as well as the transactional API. One of the outputs that comes along with any of those matches from the service is a confidence score articulating the closeness of the input term and code to the resulting set of IMO terms and mapped codes. And so we look at that on a level of 0 to 1, 0 being no match, 1 being an exact match that one of the IMO Health informaticists has at some point or another declared is exactly the same as the response that we're providing. And so on that level, maybe talk through the decision process in terms of where you set that threshold and what that means in terms of the level of confidence you have in the results coming back.
Sure, that's a very good question. So almost all the times we have to some or the other way trust an engine which produces a probabilistic score when we are not able to do deterministic matching, right? So maybe I'll walk through how we just got into the confidence level of where we are today. Around 3.5 years ago or so, when we started deploying IMO, I mean, it took us some time to understand the thresholds, first of all. And the normalized engine has evolved a lot over the period of 3-4 years for us. So when we started initially, we looked at labs because that was far more complicated. So what we did is we had in-house informaticists who actually pulled in all the codes and results from IMO and these equivalent thresholds. And we went through one by one. Actually, this is an exercise that we've done because when we actually produce these metrics and we set the thresholds, it's very critical for us on a clinical data level, right? So for us to get to that level of accuracy, what we did is our cohort was close to 60,000 rows of sort. So we had a full 3-4 weeks of exercise in which clinicians from our team, informaticists from our team, and data analysts, we went through this exercise of looking at how do we actually fix this threshold meaningfully. And IMO has a default suggestion as well, right? So any score between 0.98 to 1 is almost an automatic match. And we were basically validating that. So we were trying to validate if that sits true with all our different sources. At that time, we had 3 domains by IMO's engine, which was problems, procedures, and medications. So we picked specifically lab codes in this, and then we went through that exercise. That put us in a way where we were very comfortable in setting the thresholds on anything 0.98 and above. So in simpler terms, anytime we have something between 0.8 or to 0.98, it's close enough as a match, but there needs to be a human intervention. And then anytime it's 0.98 and above, it was comfortable for us to actually get to the point of an auto match. So that was our threshold logic to start with. Then we had to fine tune with our lab data. We worked with IMO multiple times and refine the thresholds, and each domain is very specific, right? So the recent improvements on auto domain matching and the thresholds vary on that. Sometimes you specify the domain, you get higher threshold matches versus you don't specify, it just creates an ambiguous response. So trial and error initially to the point of standardized procedures or operating procedures, which led to us define those thresholds of 0.98 to a certain extent. And medications 3.5 years ago was at a different level of maturity, but it is performing at a decent level today. So that's another work in progress on how we are actually evolving towards setting up the thresholds. But that's the exercise that we had to do internally from our side to validate these scores for getting into a confidence at the match level. Hope that answers the question.
No, certainly does, and I think it bleeds into some of the other questions that we're planning to talk through in terms of what that implementation and technology integration looked like. You thoughtfully walked us through some of the collaboration with your informaticists and clinicians in conjunction with clinical subject matter experts on the IMO Health side. Maybe talk through some of the more of the technology integration and just how you approach that, and what your learned experience was through that you can share with some of the folks that are listening in, maybe thinking about some of these same challenges themselves right now.
Sure. Like I mentioned before, technology integration. So because health data utility, we get state level data flowing into our system. We are not a single EHR system. We are not a single hospital, right? So the scale is big, but not massive like another state like California or so, right? So the scale is definitely big. When we are talking about transactions, close to 1 million plus records are just on clinical side gets exchanged on a daily basis. Pharmacy, again, very similar to that. So these are what we call as admission, discharge, transfer events, right? So when events starts flowing into our system, that triggers upstream data quality validation. So technical integration, initially the requirements that I had is to have at 2 different levels. One at a level of transactional stabilization. And the second one, which is anything that we run downstream analytics, has its own stability too. Because this also adds a layer of introducing gaps in other sources of data that flows into our system that doesn't follow our traditional integration path, and how do we normalize that? So there were two different use cases that we had initially. So technically how we approached this, we started with the standard normalization approaches of integrating this upstream and batch process. So right now we are hitting the IMO's SFTP exchanges, which again goes back to the IMO's search APIs naturally. So any distinct records that we get that are not already normalized, we pick them up, the pipelines actually package them, send it into IMO's batch process engine, and then at a agreed upon cadence, and then that provides back results, and then we just ingest that into our infrastructure for downstream utilization. Then there are other data warehouse and data lake processes that we've also embedded, in which gap data that we get, we actually ingest that ad hoc into our system, and that lands into our lake. Prior to the data landing into the lake, we run them against with the normalization engine. That again brings back just to have a layer of double validation for us in order to get it into meaningful downstream systems and fill the gaps that actually exist in the system due to this variance in transactional processing and data lake processing, which is more analytical for us right now. So architecturally, we had to place our positioning with IMO in a different way, and this might not be the same case with others. So in a way, how we are approaching it is kind of unique on how we are actually pushing that into transactional and analytical normalization altogether.
I want to come back to one of the stats that we had shared earlier, and maybe contrast that with just the how your informaticists are querying the data now with improved code. So we had talked about the improved specificity of the problem and diagnosis data specifically, because and this might not be a quantitative argument here, but I'm just qualitatively, in terms of the insights that you're able to produce on the data. Are there any particular examples that you would point to and say that this is really neat and something that we weren't able to do before?
So with respect to code stability, I think the biggest winner for us is along the lines of problems, right? So we had like close to 1.2 million distinct codes that we had to actually push it into standardization. Almost it's the way of how the free text placed in the description that we are not able to code, push it into our code systems, right? So I think I would say that 83.7 metric that you shared earlier, so the automatic resolution, so that's where our biggest pain point that was relieved per se. Every month when we actually send the distinct codes that are not normalized specifically to the problems, that comes back with a normal code set, which is what the informaticists pretty much use in order to create that soft link in our transactional data. We also have challenges in how we actually merge it into our data source, right? So we cannot kill the provenance of the data. We have to keep it as is when we actually do the quality reporting. So the soft link that we do is for public health reporting and other reporting needs from payer side and the provider side in certain cases of analytics. So we use that as our informaticists specifically use that as our source in order to perform those metrics, quality metrics. We can always go into the depth of quality metrics, which should be by itself its own topic on the different metrics that we are working on. So naturally, that is the pain relieving point for us.
Oh, great. Looking ahead, maybe I know AI is quite the buzzword, especially in the data world right now. where is, where is your head, where is CyncHealth at in terms of evaluating the introduction of any of those capabilities, or how the data that you have might serve some of those use cases?
AI is too generic of a word for me to just bring that into the topic. Even before we had large language models pick up, our patient matching engine actually uses a probabilistic or a fuzzy logic matching for us. So it uses to a certain level of advanced machine learning approaches to actually score the weights from a demographics perspective. So I don't see this as a new concept for us, and accommodating AI, or in this case specifically, I would say advanced natural language processing for us, right? Or if you're thinking about putting a large language model on top of this free text that flows in, that is quite often not able to be 5% of the data is never in real world data, 5% of the data is never resolvable. What if you get columns with empty cells? You cannot actually do anything. So it's highly repeatable challenge that we have in any source that we have. But I'm thinking from adoption perspective, we've been very early in this game on adopting such approaches from a demographics perspective. So IMO into the play that just expanded our demographics into more clinical context of the patient, pharmacy context of the patient. We have not explored the social care context, but naturally it will be the next approach in which how we run that into our system. It's there, and the way how we approach it needs to be also tied upstream when we actually push this data into reporting needs. The knowledge that we use here at the part of AI and the decisions that are made by the systems need to be transparent and explainable back to the data producers if they are actually using the reports, or back to the for example, public health consumers who actually uses this data for reporting functionality. So at both the sides of it, as long as we keep it as transparent as possible, and this is why we are calling a specific match as a match, and there are thresholds and there are standards. And I know in case of patient matching, specifically from a demographics perspective, ONC, the Office of National Coordinator, has come up with several policies in which these thresholds and measurements are going to be standardized eventually in the future, right? So thinking about it from a policy aspect of it, so that will actually get us to the point of adoption and trustability of these scores, right? So end of the day, it all matters when the trustability of these algorithms are very high and certified by an entity that is forming a policy at the national level, would actually be very meaningful for us to adopt. Technically, pushing a Gen AI on top of matching is not a complicated thing, right? I mean, being a data scientist, I can just think through those workflows, and it's very easy to actually pull something like that together with the vast amount of data that we have in place with higher accuracy levels too. But what happens next? How do you interpret it, and how do you actually explain it? And the decisions that are false positives, or to the point of how the scores are miscalculated, how do we actually hold accountability across, and the challenges on governance of data? So those are the things that are more interesting for me at this point of time, not the solution at the level of AI by itself, right? So because to me, I strongly believe the AI community or the data science community has come really far in actually handling this in a way that is never actually a technical or data level challenge, but it's more along the lines of the people and the process and the policy that actually facilitates the adoption of it, which actually puts an entity like health data utility in a rather challenging situation to adapt.
No, I'm sure. No, it's an incredibly nuanced topic and a very thoughtful answer. Well, I know we're coming up towards the end of the planned talk. So if any of the thoughts that Naresh has shared based upon his experience have triggered questions, the Q&A is there. I encourage you to those in. I'll lead off with a few that have been submitted already. I know your perspective, Naresh, is specific to CyncHealth and as a health data utility, and how you're thinking about the role that you play as an information exchange. Certainly not the exclusive audience set that we have today. So maybe you can inflect your experience for a second to some of those that are coming more from a health system or provider perspective, as well as those that are thinking about just the general work of aggregating data, be they in health tech or payer or life sciences.
So, I mean, if I'm just probably catching the question right, so what kind of suggestions from the producers of the data that we would actually look into, right? So, I think if all the challenges that we are trying to deal are step two for us. When I say step two, the step one is at the point of production of data. So, which is truly the upstream for any system that actually consumes the data, like a health information exchange or health data utility. It is relatively complicated to actually fix all the quality challenges at the production of data level, but being able to leverage, or the ability to leverage, a terminology server at upstream is often discounted due to the complexity of such engines, right? So I think the consideration from the provider perspective that I would, or possibly suggestion, right? I'm sure every EHR system has a terminology server adapted to the ability to actually form consensus across the nuanced workflows, coding methodology or data input methodology, and tying them back to the standards. That needs to be stabilized to a certain level, and it can be stabilized in API-based ecosystems. And that's pretty much how the evolution of FHIR APIs and FHIR terminology servers are all together. One approach that we have actually taken into consideration is, I know this is going a bit beyond our topic of what would be the provider suggestion, but we are actually moving more into FHIR-based exchanges, right? Nationally, that's one thing that we are trying to do. And CyncHealth has already done deployments in Iowa, state of Iowa specifically, in exposing FHIR-based APIs. So when we started working on that specifically, one of the challenges that we ran into is conformance of FHIR data sets. So the conformance of FHIR data sets, the challenge that we are running into is mainly because whenever we get the raw data from the facilities, the quality of data actually influences our conformance. So being able to actually look at the upstream and fix the quality upstream would be the most fundamental and foundational thing that we need to approach together. And leveraging a common terminology server and APIs along those lines would actually be very meaningful. And I mean, that's foundational for any sort of data generation or data production entity in the patient care continuum.
I know you mentioned social data being another step. What would be next after that? Is unstructured text part of the list of needs, or is there another place that you're seeing regulatory wins and your data senders and recipients pushing you before?
That's a very good question. I see multiple things. I mean, not to boil the ocean here, but genomic is one of the biggest challenges, and standards are still evolving. Patient-generated health data, that's another, right? So the standards on that is also evolving. IoT devices and data coming through that, which would be very much of a key for point of care decision making, and being able to actually look into stability and standardization on that is again an extended topic of sort. There are actually national level policies that are actually being brought forward. And I mean, when it comes to devices, FDA has its own layer of protection in order to bring those data sets into play. So multiple areas that I can think about, which can possibly be a hot topic of itself. So at the moment, I can think about these two, genomic and wearables.
Yeah, large amounts of data and complexity indeed. Naresh, I know you walked through some of the decision-making process, and you talked to the importance of terminology services. Certainly we're not the exclusive player out there. I'm curious, just from your experience, what has confirmed to you this partnership? Maybe maybe one thing that you knew going in that led to that decision, and maybe another thing that surprised you since since we've been on this journey together.
So I'll be transparent here. The one thing that I looked at is very much more of a modular infrastructure guy. All our systems from day zero, when we were thinking about producing and getting into architectural place, microservices, being able to perform autonomous functions for its specific needs. So not every time MSA or microservices architecture is going to work for its need, but the way how we looked at from IMO's perspective is it was very straightforward, and us being able to talk to an API, get these standardized codes back, and then use it into our system, however we intend to use it. So that level of flexibility was one of the key things that we had. So that basically moved our decision towards. Then the second, or surprise, I would say, is when we started, there's pretty much medications were at a different level of stability. So it evolved over a period of time. So it is in a decent shape as of today, and we are able to move forward. So those are the two things.
Yeah, no, certainly a large area of focus, both in meds and labs on our side has led us there. I think we're coming towards the ends of our questions here, Naresh. Maybe any final thoughts to offer as before we put a bow on the conversation this afternoon.
As far as final thoughts, yeah, one of the key things that I mentioned earlier is about upstream quality, right? So there is enormous amount of time and resources that has been spent with any of the analytics or any downstream systems that actually utilize the data from electronic health records. It is known to all of us at this point in time. There are several publications out there that talks about why quality is such a big deal, but it still remains as a white elephant, right? So nobody talks about it. We talk about all these interesting new approaches on how we would actually throw Gen AI on every single thing, but the foundational layers of this is how do we get to high quality data, and how do we actually certify them in a meaningful way? And what is the consensus across? Because when I say 99% of the quality of data is complete from my side, when you look at it from a clinical perspective, I look at it from a technical perspective, they are different things. They're completely different things. So to be able to get to that level of consensus, it's always a challenge. And be able to leverage systems like normalization engines in a meaningful way to actually get to that level of maturity. This is foundation, and this is foundations of MDM and how to handle data. And I think my last few words are very specific to that, being able to understand upstream quality and make it as a meaningful decision point upstream, because any systems that are going to consume that down the line will be severely impacted, even by a simple form that has a value that is not present when it has to be present. Validation at the upstream level will actually have downstream impacts at several layers. It includes now USCDI V5, which has got far more complicated requirement, and to be able to implement at the level of state level scale or national level scale, it needs a lot of standardized engines to actually produce that into an efficient solutions for interoperability to be more semantically operating than just at a syntactic interoperability level.
And certainly meaningful statement. I really appreciate that lens on the importance of that foundational data, and not, the promise of AI and large language models, even in that kind of generic, far-reaching perspective. I think that there's certainly a lot of fluff out there, but I think that discipline approach that you espouse is important. Last question before we wrap up, Naresh. We've talked about the broad perspective of data quality. We've talked about some of the specifics around how you approach that from both a clinical and technical perspective. Maybe going down even deeper. Do you have an example to share? Maybe even if it's not a specific one, just the way that you think about the folks in Nebraska and Iowa, and the patient data that you are housing and cleaning up. What's the felt impact to them as you think about the work that CyncHealth is doing on a day-to-day basis?
Maybe I'll possibly pivot that question more into public health, because that's one of the areas that heavily gets impacted downstream due to this upstream quality issue, right? So being able to produce a metric back to public health to show that here is how the standards adoption at the state level is profiled by a specific type of data that we get in, whether it is ADTs or labs or medications, or so being able to get to that level of quality scores has a direct impact on how public health can perceive and modernize their systems and fill the gaps in to actually get it into their programs for meaningful decision making. So we do that regularly. We do that periodically, like every month we actually produce like a big picture completeness score back to the public health, and that is utilized meaningfully in order to drive our decisions towards the points of investment from the perspective of where should we focus more on onboarding, where should we focus on policy, and where should we focus more on defining our specifications more clearly. There are optional elements in our specifications that quite often they are not optional, right? So it's truly when you say optional, but they actually get to the point of decision making from a public health perspective, they are needed. So the difference in that gets called out easily when we actually start sharing these scores. So I think that is a direct impact that I see from a facility or a patient perspective, right? So it might have been a point of entry that was never perceived in a way how this could be utilized for decision making at a policy level, but that's a full gamut of how point of origination to point of utilization, what is the impact?
Yeah, no, that virtuous cycle. I think we've seen a lot in terms of how data generated can then influence the point of care once again when you're able to draw meaningful insights from it. Well, Naresh, I thank you so much for joining us today. Jory, I don't know if you have any final housekeeping for the conversation.
Yeah, thank you both, Naresh and Matt, for that awesome discussion. I know that there's a lot of other ways that the attendants can spend their time. So thank you everyone who joined today. I will be sending a recording later this week, so be on the lookout. And if you had any questions regarding, IMO Health Solutions, please email our sales team at sales@imohealth.com, and we'll get you in touch with someone. I hope you both have and all have a fantastic day, and thanks again.